The broadcast is now starting. All attendees are in listen-only mode.
Okay, good afternoon, everybody, and this is Dr. Mansour, and this is the seismic review for the second quarter. Today is April the 5th, 2020, and this is the first section, as you can see here by the schedule here. So the second quarter review, basically based on the textbook, which I used it in the first quarter, plus the 6-6, which has all the problems I have in all my books. The textbook and the 300 and the 2 practice exams. And the course basically consists of 2 parts. The first part is the live workshops, the one we started just right now, 28 hours, plus the 55 hours or even more, I believe, until last night. My staff, they are working from home to set up everything to make it ready for you for the on-demand. So the on-demand, you will get a username and password from us, where you can get access the on-demand, which is 24/7 from any media. And normally we keep this for 150 days. So you will get access for 150 days. And I go beyond that, to tell you the truth. In the past, even my staff, they are not happy with that, but normally I say that's fine. Let us, for whatever reason, if the engineer couldn't make it, let us help. So 150 days, according to our website and the brochure, is 150 days from the first day of enrollment. But because the exams were canceled and we have this corona issue, I am flexible, and as I said, I am flexible even before the corona issue. So I will do my best to help you guys to pass this exam and get your license as soon as possible. Just stay safe, and I will do my best, as I said that. So the first part, as I mentioned, it is the 28 hours. And this is equivalent to some courses available in the market. They teach the entire course for 28 hours and that's it, or over 28 hours. And here we have 28 hours live workshops, and I will go over them shortly, plus the 55 hours or even more, the on-demand. So you're supposed to receive from us some kind of password and user's name. So today is 4/5/20, and this is a seismic second quarter. So the live webinars, those are 28 hours, and the on-demand, those are more than 55 hours, and this is 24/7 available for you. In order to get access to the on-demand, you need a password and username or user's name, and this must be provided by us. And my staff are working right now. They are working remotely, not from the office, and I hope that this will be available to you as soon as possible. If there is a problem accessing this on-demand recording, this recording, by the way, this is what it was recorded in the spring 2020, which is the last quarter, or the first quarter, if you like to call it, first quarter of 2020, which is the new code, where the new code or the new codes were adopted. So the current codes, or the on demand, are based on the current codes, okay, which is basically the California Building Code CBC 2019, which is based on the IBC 2018, and the major code is the ASCE 7-16. Plus the other codes are still the same. The ATC 20, ATC 20-1, ATC 20, ATC 20-1, the timber or the timber design book, the textbook by Dr. Breyer, the masonry, and so the timber book. This textbook that I use it for about, I don't know, 20 years or 25 years, I don't know, meaning the design of wood structures by Dr. Breyer, the 7th edition is still the current, and this is Dr. Breyer's design of wood structures. So this is or wood design. Let me use this standard language, wood design. Plus the special design provisions for wind and seismic of 2015. This is a special design provision for wind and seismic 2015. This by American Wood Council, AWC, a small publication. This publication that I showed to you more than once. Let me see if I can locate it very quick. Special design provision for wind and seismic, which is this one here. Special design provision for, this is 2015 edition. Even 2018 is available, but the code or the current test plan is based on 2015. So I extracted what I believe that you needed from all these references. Total, they are 9, I believe. 9 references, yes, they are 9. They are listed at the beginning of my textbook under the green tab. The green tab is special seismic exam, and they are no, I'm sorry, 6. The 9 is the other course. Sorry, I mixed codes. Too many codes. Too many. Let me get the other book. I believe the other book, the printing. There was one time the printing was bad, so this you can. I believe this is. I call it the correction copy. At least I can write anything. Yeah, this printing is the right one. So they are 6. No, not 9, as I mentioned. Sorry. The other exam. So the 2019 California Building Code, Volume 2 only. You need Volume 2 if you decided to purchase that, or you can use the IBC. I prefer the IBC. IBC is much simpler and cheaper. If you like to purchase, you can purchase the IBC 2018. It's one volume. The IBC one volume without the commentary, but sometimes they have 2 volumes where they can have the code and the commentary, which is explanation of the code. So this is one reference. The second reference, which is the minimum design laws and the associated criteria, okay, for building and other structures. This is a new code, the ASCE 7-16-10 is gone. This is a special design of wind and seismic, the one of American Wood Council, AWC. Special design provision for the masonry, building code requirement and specification for masonry structures, another book by ACI 530, American Concrete Institute. ATC 20 and ATC 20-1, second edition. And finally, number 6, Dr. Breyer's book, which is Design of Wood Structures, um, the 7th edition, 2014, based on the ASD and the LRFD, the allowable stress design and the load and resistance factor design. So both of them are, both design philosophies are included in the book. So those are the references, plus the standard test plan, which is, I needed to be aware of that. So any test plan that I highly recommend you to visit the California website, California board website, which is available on our website, California board, to see all the updated information and updated um, instructions or news, especially in these days. I monitor this very carefully or frequently, if you'd like to call it that way, California Board and NCEES, to see what is the status of the exam, new codes, new regulations, new standards, a new calculator policy, because they change from time to time. Okay, so the seismic review for this quarter, which is the second quarter, seismic review. I decided yesterday that I will make it you can give the ID. This is it has ID, the one you use it to join me today. It's only one ID and one time. ID 719 049 035. So basically, you go to www.joinwebinar.com and you enter this ID. Plus, I believe we ask only for their email, your email, and you are enrolled. One enrollment for all. One enrollment for all sessions, so you don't have to do anything in the future. Just come on the day of the meeting and you will join me. If you have any technical difficulty, please let me know if I can help. Normally, this is by a company. It's called gotowebinar.com. I know nowadays, because of this coronavirus issue, we have sometimes, and you experienced this one time with me, where I lost the connection. And yesterday, for example, I tried to send an email. It took 2 hours from me. The internet was down for some reason, and the things are not working. And so this is the ID for this quarter. Second quarter, and I made it free. So free means that you can give this to a friend or a neighbor or co-worker, but they will not get access to the on demand. The on demand is not for free. The on demand is yours only. You cannot give it to anybody, because uh, um, we get a report from our company. The company is hosting that. So the 55 hours, no, you cannot give it to anybody. Yes, this 28 hours, yes, they can join me during the workshops, but the on demand, we will know exactly from the company, because the company charge me on that. Charge me for every access you make, and every time you spend, I will get a report from them. So it's not for free. So the only thing that you can give is the ID. If you'd like to invite anybody, a friend or somebody or a coworker, to give him that to attend the 28 hours only. 28 hours only. But the 50 hours, no. 55 hours, which is a course itself, because the 55 hours, basically, this is a course I taught last semester. This is the entire course where I went from chapter to chapter, and those who attended the first quarter, they know exactly what I'm talking about, entire course. And we covered it to the best of my knowledge very well, and I did all my best to explain all the topics, all the subtopics, and we solve many problems. The workshops nowadays, okay, or this quarter, the workshop is workshops. Um, Let me write it correctly. Workshops will be devoted entirely to solve problems. Solve problems. Plus the concept. Any concept is not clear to you, I will be glad to explain it. So for those of you who are attending the class the first time, okay, what you need to do, you need to go and watch this. You need to watch the class, okay? The on-demand by itself. Some other vendors, they sell the on-demand by itself as a course, and that's it. Okay, here I am giving the on-demand plus the 28 hours, which is a live class to come, so we can chat with each other and we can go over problems. I can explain topics or subtopics. But for those who are attending the first time, it is the on-demand is the one you need to watch, and you are going to hear the same thing. If I'm teaching the course again, you will hear the same song. It is nothing, and this is available for you 24/7, as I mentioned. So please do your best to watch this and solve problems. And after that, when you come to the workshop, you will be able to ask all the questions you have. We send you the exam, the second book, the 6 to 6, the CBT. On a green USB like this. You can install it in your computer once, okay? And it does have a password. It will generate password. Copy the password. It does have all the instructions. Copy the password exactly. The password exactly as generated by the computer. We don't involve in that. This the CBT, the computer will generate the password. The programmer that I hired, they wrote it that way. Enter the password exactly verbatim. The computer will generate 55 questions, and it will give you 2.5 hours to simulate the actual exam. And after you finish, you'll get a score, and you can get a printout of the questions and your answer and the correct answer. And it gives you the problem in the 6 to 6 book. Where is this problem is? Because the computer will randomly select 55 questions from the 6 to 6, which I should mention. The 6 to 6, there are some overlapping problems. By the way, the problems are repeated twice sometimes because they are mentioned in some books and repeated in another books with some kind of variation. So I needed to take it seriously, even if you feel that this problem already repeated before. Look at it closely and do your best. So if you have any problem with loading the software, running the software, I don't know how to fix it. I will forward your questions to the webmaster. And so far, we don't have any or few problems, very few problems. And I will do my best to help you as much as I can. Okay, this is just introduction. So let's go to the business of working problems and the way that I was hoping to do it, but I didn't get a chance to. That maybe I will do this. Okay, next session that I will let me get my book here first of all, just to make sure that because I have too many books next to me. So I don't know what is my 6 to 6 with the cover. Okay, but unless I give it away. Okay, unless it is here somewhere, hidden somewhere. Forgive me, just let me get my stuff here. Okay. So I hope that everybody is safe and you hear the news every day, and I hope that all of you will stay safe and do your best, and I will do my best, and hopefully that we can everybody to be safe during this crisis. Okay, let me just, I'm looking for the other book. Yeah, here it is. I found it. Here it is. It was under the transportation books. This morning I was teaching transportation. So the 6 to 6 try to do all your best, and I will do all my best. So the course, as all of you know, consists of 16 chapters. So 16 chapters, and I did my best to extract from the codes what I believe that you need. And if you find a typo or a mistake or an error, normally the first edition after the code is changed, sometimes they have some typos, and already we saw some of them. So please let me know if there is a mistake or a typo or anything I need to review. I will be glad to review it. For example, if you have the textbook with you, I can point out a couple mistakes that we correct them in chapter 6. Sometimes it's written twice. One time is correct and one time is not correct. In chapter 6, when we calculate the period T, this equation here, I believe we corrected that where they introduce the C sub Q. They would like to have this equation in metric and in English. So this is page, by the way, page 199, text. Okay. So I believe I corrected that. This was something that if you go to chapter 10, when we are calculating the rigidity for a shear wall, H over D, let me, if I can locate it very quick, I will tell you where it is. It is mentioned in chapter 5 and it was correct, but here, yeah, when I talked about shear walls. So if you go to the text, again, the text, let me just make sure that I'm using only 2 books. So when I say the textbook, this is the textbook. Seismic Design for a Professional License. This is the textbook. And when I refer to the other book, I refer to it as a 626, book number 2. So if you'd like me to write down book number 1 and book number 2 will be a good idea. Sometimes I do that with other courses when I have more than. So this is book number 1, which is a textbook. I call it textbook. And book number 2, which is a 626, which is a supplemental book that does have all these fancy questions or all these questions. So I will call it book number 2. This is number 2. Okay. Which is the supplemental book or the 626 book, whatever you'd like to call it. Supplemental book or the 626 book. So if we go back again to the textbook, just to make sure that in chapter 10, in calculating the rigidity R, I believe something is missing. It's mentioned in chapter 5, correct, but when it was copied to chapter 10, for some reason, it was not. So if you go to chapter 10, okay, I'm talking about this equation here. Let me make sure that, and this equation here on page 378, textbook. You will find these 2 equations identically. I repeat them here just to remind you in chapter 5. Let's go to chapter 5 so we can compare these equations. And Okay, to make sure that we are, this is, excuse me, this is delta C, which is equation 5-13, which is, this is the correct equation, 0.4 H over D cubed, div plus 0.3 H over D. This is 5-13. I will call it 5-13 also. Sorry, this is for the cantilever. Yes. So this is 5-13, equation 5-13. This is on page, okay, 152. And the second equation, which is, oh, so the mistake is in chapter 5. Now I realize, okay, here it is. If you go to page 153, this equation 517. So it is missing here H over D. Okay, here it is, which is the second equation, which is for the fixed. This is on page 378 of chapter 10. You will find the H over D is here. So it is missing in the chapter 5. So it is in chapter 10 was correct. I reverse it for some reason, but here it is. I said, why? I'm saying that here it is. So this is on page 153. Go to page 153. All what you need to add H over D here for this equation. Okay. So this is something that, which is mentioned here, by the way, is the previous page. This is the equation. Okay. But, so the H over D is over there, but it was dropped. So this equation 513 is correct. And the 517, equation 517 on page 153, please. I need to add H over D, but multiply 0.3 times H over D ratio. And so in this case, the two equations in chapter 5, they are matching the equations in chapter 10. Okay, this is one thing that one of you pointed out. Thank you very much. Yeah, if you have doubt about any. The other thing that we corrected together in the seismic design category, it was copied. It is in chapter 13. Can you go masonry? Can you go to page 440? Page 440. At the top here, which is I extracted the masonry seismic force resisting systems, SFRS. I extract them from table 12.2-1, this big table. But here they says seismic design category B, no, it's supposed to be, as in boy, C, D, E, and F. Excuse me. I do have an allergy. In fact, I went to the doctor on Friday, not physically because they don't allow anybody to go to their place. So over the phone, I saw him last year about the same issue, allergy in the valley is so bad. So I'm taking medication and some kind of reduce the allergy effect. So, and okay, I hope this is the case. So it is B as in boy, and I am on page 440. Please let me know if you are not seeing the same thing I'm seeing. Please let me know, and I will be glad to make sure that those are the mistake, the typos or the errors, mistakes, whatever you'd like to call it, to the best of my knowledge. But nobody above mistakes, and we need to do our best in order to catch any. And if I catch any, or sometimes I skip a step, or so. So the 16 chapters, they are covering the topics related by the California board about the seismic exam. If there is any topic that you feel that it needs a little bit more of discussion or more of explanation or more of emphasis, I will be glad to do that. I have no problem with that, and I will do all my best to help all of you to prepare for this exam. Here I have 626 problems. My intention was, but because of a lot of things going on, including my schedule, my intention was to extract some problems from here without the solution, just the problems, and I put them in a form like um, um, whatever you call it practice exam or and I need you to solve it in advance before you come to the class, and after that uh, uh, they are coming from the book. I'm not going to invent more than or more than what I have, or I don't like to reinvent more than what I have, or maybe it's some addition here or there's some problem here or there. I always modify the problems, but I believe those who studied my books before, even without taking the course, was sufficient for them to pass. They told me, Dr. Mansour, your books self-contained, and we were able to understand everything because I explained as if you are sitting in a classroom, and I try to explain as much as I can, but nobody above mistakes, and nothing is called complete work. Always there is a room for improvement or um, enhancement, uh, continuous improvement. So this is my intention. Probably next time I will do that because I was really busy with tons of things. This issue about family, and so next time we're going to meet 1 week from today. So it is 7 days. So probably I can work on something and send it to you. And all these lectures, by the way, starting today, will be recorded also, or are recording as we speak, and somebody will remotely also get access to my computers and load it on the website. And I believe, if I'm not mistaken, I asked them to put it under um, 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 let me see if I can get uh, um, um, the website. I believe they are working on something. It will be under a free workshop videos. Yeah, I asked them to modify the home page and they are working on it. So when you click on it, it will take you to the free videos for the workshops. I have it this summer, the AM, Civil Brits AM, Transportation BM, and the Construction BM. Those are, and also you'll find it under Seismic also. Seismic will be here. Live courses, this is later on in July we're going to start. And also the surveying class, I'm supposed to have a surveying class on the 18th of this month. It's still scheduled for the 18th. I don't know if what changes. As you know, things are changing every day. So we still have a survey class on the 18th. For 18, this is a course using all these 4 books here. This is the second edition. I'm trying to modify also my books to come up with the second edition. Hopefully it will arrive on time. With this Corona stuff, there is a delay for everywhere, but I will do my best. So going back to the to the website, you will find it here. So these videos, it will be available for you and for everybody because they are free. As I said, I decided to make it free this quarter, so to help everybody. Okay. So after this, let us go to the business, and the business is problems. Okay, so if you, I can open just the book and look to a problem. And if you don't have the book, I have no problem. I will be glad to send what I'm going to cover today. So if you have the book, that's good news. If you don't have the book, it's still good news. That means that I will make a copy of whatever problems. But for those who are enrolled in the class and those who have the book, because some of you purchased the book without taking the class. So you have the book without, okay, taking the class. I have no problem with that, as I told you that. So if can we go to problem, I open the book randomly, and 375. And I will walk, some of you are new, I will walk you a little bit through the theory. So let us read the problem. And the most important thing in any exam, specifically seismic and surveying, because you have only less than 3 minutes per question, because they give you 55 questions and they give you only 2.5 hours, as all of you know, 2.5 hours, and they give you, okay, 55 questions. So if you count or calculate the 150 minute divided by 55, and it's less than it's 2.7 minute per question. Okay, so don't assume that the questions have the same time as the national exam. The national exam, as you know, 6 minutes. They give you 4 problems in the morning and 4 problems in the afternoon, and they give you 4 hours. So the time, okay, for the seismic and surveying questions is less than half of the time they give you for the national exam. So I don't like you to assume that you have plenty of time. No, it is less than half. And this is the impression that some engineers, they assume, and they go, so your speed here, your speed for the seismic and surveying speed, okay, it should be twice. Okay, or okay, at least more than, okay, 2 times faster than the national exam. Even the national exam, I know we are saying that we don't have enough time. Even the seismic and surveying even made it worse, okay, or they made it worse for us by giving you less than half of the time for each question. So we need to read the problem carefully, and after that, so 375. Okay, the wood structure panel roof diaphragm of a warehouse 1-story building is shown, a plan view. So we need to pay attention if this is a side view or a plan view. This is a top view or a plan view. Top view or a plan view, or top view. You are okay. The calculated roof diaphragm shear capacity 250 pounds per linear foot in the east-west direction. There is something a little bit missing from the picture. There's supposed to be this arrow here, and it says north arrow. So this is something missing. Okay, for some reason, I think when they crop the picture, when they draw it and they crop it and bring it from AutoCAD or MicroStation to Word, it seems to me that this is missing. So please, this arrow here indicates the north arrow, because the direction of analysis is very important. So in the east-west direction, if this is the north, this is south, as all of us know, and this is east, and this is west. In the east-west direction, the roof diaphragm is adequately anchored to the shear walls. And the question is, the shear along the south wall is most nearly. Here, from the plan view, we have these solid lines or solid dark lines. These are indicating there are shear walls. Okay, walls. Okay, these are walls. This is the standard notation that they are using. But this light here missing, this is storefront windows. These are opening, or is an opening, indicating this as, so we have walls, east, west, north wall, and south walls. And he would like to calculate what is the shear along the south wall. As you know, in the course in chapter 9, and I needed to be ready for the exam such that when you read the problem like this, you should know where is the equation. Nobody will ask you to memorize equations, but the moment I read the question, I should say, okay, he's looking for what? This is given. Since I understand what are the given information, I will jump to find. And the shear along the south wall is most nearly. He's still looking for tau wall. The shear along the wall. But which wall? The south wall. I have the south wall is 40 feet and 40 feet. One piece here and one piece here. This we call it south wall. This is the north wall. This is the east wall. This is the. So what is given? If you look to the equation, which I'll show it to you right now, is the equation 9 dash. Do you remember chapter 9? Okay. 9 dash 2. Let me see if I remember this equation correctly or not. No, 9 dash 3, sorry, and 4. 3 and 4. 9 dash. This is the tau wall. Here it is. This is the equation 9 dash 4. This is on page 338 of the textbook. One equation for the tau, or will sometimes we use V, lowercase v. The same page 9 dash 3, it is the diaphragm shear, tau diaphragm along the shear wall, along the shear along the diaphragm. This is the shear along the diaphragm. We call it tau diaphragm, and this is the tau along the shear walls. So diaphragm shear, and this we call it shear wall shear. This is a tau diaphragm or lowercase v diaphragm. And this is a tau wall, as indicated here, or v wall, as I told you that they are using this in the seismic design professions. So, but the two equations, 9.3 and 9.4, based on something is called F, which is a total force. F is the total load or force in the direction of the analysis, which is the W times L, if W is given, or W is uniformly distributed load. Okay, which is, if you go to the previous page, I'm referring to this drawing here. It is, if this W is given, which is a load. This is a lateral load. Lateral load. But he gave me something here. He said that the calculated roof diaphragm shear capacity is 200 pounds per linear foot. I need to translate this. What is this? Okay. We need to understand this very, very, very well, please. Okay. But this could be the difference between getting the right answer and getting the wrong answer. If this is the lateral load, W, or this is the tau diaphragm, because there are two numbers. I will explain it one more time. Because if we can differentiate between these two, that means that we are in very good shape. roof diaphragm shear capacity. I needed to, I will take this to the, so generally speaking, irrespective to the number of walls and the openings or not, we know, let's assume that we have a wall here. Let's assume this wall here is short wall like this. Let's assume that we have a wall here, complete wall. And we have a wall here. And we do have a wall here. Different configuration from, sorry, my drawings, sometimes I use a straight edge because try to make nice, and this is normally the direction is very important. This is why we need to know what direction. So this is the north direction. And this is, I will call this is wall number 1, number them wall number 2, wall number 3, and wall number 4. And let's give some dimensions. Okay. So assuming that this is centered, assuming this is, okay. So this is 15 feet, and this is 20 feet, and this is 15 feet. So the total here is 50 feet. Let's assume that this is 30 feet, and from here to here, this is almost twice, so I'll make it 60 feet. And this wall here, since this is 90, I will make this 40 and 50. So the opening is 50. At least for those of you who are attending without the book, you can follow me, and those who, if you, this is 50 feet and this is 40 feet. This is a plan view or top view, also plan view of a story of plan view or top view of a building. If the lateral load is given, which is the lateral seismic load is given, obviously I number these walls. These are the wall number. This is wall number 3, wall number 2, wall number 1, and this is wall number 4. Let us assume that I give you the load. So I said that the load from, it can come from east or west. It does not make any difference. So I give you a load in the east-west direction. To be 80 pounds per linear foot. So this is W. Sometimes we call it W, uppercase or lowercase. W sub S for seismic. This is 80 BLF. Here we can calculate equation 9-3 and 9-4, the one I was referring to. Equation 9-3, it says tau diaphragm or V diaphragm. Assuming that this diaphragm is flexible. Let us mention this statement, and I can explain the difference between flexible and rigid, but flexible diaphragm. So this equation 9-3. The 9-4 is a T wall or V wall, which is 9-4. These are non-code equations, and I will elaborate this after I finish this. Because I took you all the way to chapter 9 to show you the equations, but if you don't like to dig into the chapters, I provided a summary at the beginning, and I'll show it to you. Diaphragm, what is a diaphragm? Diaphragm is the roof of a building or the floor of any building. This is called a diaphragm. Diaphragm is horizontal or nearly horizontal element that will transfer the lateral load to the vertical resisting elements. These definitions at the beginning of my book, I defined all these things, which I did not create them or I did not invent them. I took them from textbooks or codes, because if a code has a definition, we have to stick with the definition of the code, because this is what they are going to test you. Assuming that you have a building like that. So what is a diaphragm? A diaphragm is horizontal or nearly horizontal. This is the floor of a building. This is a diaphragm. This is a diaphragm. This, the entire thing here is the roof is a diaphragm. So this we call it nearly horizontal. Horizontal because of the slope. If this is horizontal or nearly horizontal. So this and this together acting as, because this is one piece. This is the roof of a building, roof. So this is a diaphragm, and this, what is the purpose of a diaphragm? Diaphragm is a horizontal or nearly horizontal element that will take the lateral force, seismic lateral force. If you remember, we have the base shear, V. Do you remember V? V is the base shear, it's not the shear force. Base shear, per the code, which is equal to C sub S times W. Do you remember this equation? C sub S times W. C sub S is the seismic response coefficient, and W is the seismic dead load. Seismic dead load. And this is the seismic response coefficient. Seismic response coefficient. And the more you write, the more you will get familiar with these terminologies. And so if you remember, the V was calculated using this equation, for example, based on this approach is called ELF. Do you remember ELF? Equivalent lateral force procedure, ELF. So I have F1 and F2 and F3, the force at each level. Who is going to take care of these forces? The diaphragm. Diaphragm will take it to where? To these columns or shear walls. These are the shear walls. Shear walls. Vertical resisting element, shear walls. So the shear walls or the frames of a building frame, if a building frame exists, will take care of the lateral. So these lateral forces will go through the diaphragm. Diaphragm will give it to the columns, and the column or the shear wall, and the column will take it to the foundation. And this is our ultimate goal, is to get the base shear, and this will be the distribution. Do you remember the distribution? We talked about distribution, chapter 6. Distribution, when we said that F sub X is equal V sum CVX. This is a vertical distribution factor. Vertical distribution factor. C sub Vx. So the distribution will be done, and this force will be determined. This is not the story right now. The story that I'm telling you, that a diaphragm is the roof of this building. But I try to elaborate a little bit, at least to remind you with what we are talking about. So this is something just to explain what. So this is given This is given as the seismic load. So we talked about something is called F. Do you remember the force F? And this is what's given in the equations 93 and 94. This is called F. F in this case is equal what? Which is a total force or total load is 80 pounds per linear foot. I know this dimension here is 50 feet. So I will say that it is 80 pounds per linear foot times 50 feet. So this will give you 4,000 pounds. This is called total lateral force or total lateral load. Since this is a flexible diaphragm, so half of it will come here. This is F over 2, and this is F over 2. So tau diaphragm, if you go and look to equation 9-3 one more time, where is 9-3? Just to, it's F over 2, equation 9-3 is F over 2, half of the force divided by D. We need to be careful what is D and what is L. Very important. Do you remember that in chapter 9? What is D and what is L? D is the depth and L is the length. L, we have a dimension parallel to the load, a dimension perpendicular to the load. Dimension parallel to the load, as you can see, the load is coming this way, east-west, and there's a dimension perpendicular to the load. We call these chords, in fact, this will be like this. This is going to be like this. And this is going to be like this. This chord will be under compression, and this chord will be under tension. The boundary elements of the diaphragm perpendicular to the load, we call them chords. And this was illustrated in chapter 9, but since we are on page, the same page were the equations, here it is. This is the load, seismic force coming this way. So we have one side is compression and side is tension. We call it chord force, and this is tension, and the other one is called chord force compression. Do you remember this 3D view on page 338, please? So that this dimension and this dimension, which is perpendicular to the load, we call it L for this direction. So L. So this dimension here is L. So always the length is the dimension perpendicular to the load, and it's mentioned at the beginning of the book. And this, okay. The other dimension from here to here, we call it D as in David or doctor. The reason that we don't use W here because we are using W here. So the V diaphragm is equal F over 2 divided by this length here because the diaphragm exists over an opening. So 50 and 40 is 90 divided by D. So in this case, F over 2, which is 2,000 or 4,000, make it 4,000 divided by 2 divided by 90 feet. This will give you PLF, pound per linear foot. Because this is pound, and so it is 2,000 divided by 90. It gave you 22, small quantity because I just made the problem, 22.22 PLF. What do you call this? This is called the diaphragm shear, or the shear along the diaphragm. So far, so good. This is just a problem. I made it in order to introduce you to the actual problem, problem 375. This number, the 250, is it the load or the diaphragm shear? And this is the key to the whole problem. We call this is load. This we call it seismic load. But it's given to you as a distributed load, which we call it W sub S, like the 80 pounds per linear foot I gave you, and you multiply 80 or multiply 80 pounds per linear foot times this length here, because every foot has 80 pounds. So if I have 50 pounds, this will give me 4,000 pounds total, which is a total load F, seismic load. Here, whatever the number is. But we just calculated something, which is the 22.22. This is called the tau diaphragm, which is the diaphragm along the shear. So the diaphragm along the shear, let me use a color here. This is like that, tau diaphragm. The diaphragm shear exists over an opening, because the roof existing over an opening. Have you ever seen an opening does not have a roof? No. So this is the tau diaphragm. So the question is, this 250 pounds per linear foot, is it the load or the tau diaphragm? No, it's the tau diaphragm. So he gave you the tau diaphragm directly and is asking for the tau wall. But he's asking for the tau diaphragm, tau wall, sorry, it is on the south wall. But let me ask you, if he asks you the same question, that shear along the north wall is most nearly. Along the north wall is this one here, and I'm going to use a different color. It is still 250. Tau diaphragm and tau wall are equal. The tau wall is in opposite direction. Here it is. With the north wall, it does not have any opening. So this is the tau wall. So what is the relationship between the shear along the wall and the shear along the diaphragm? If there is no openings, they are equal. And this is why, let me ask you another further question. What is the drag force here? The drag force is 0. Do you remember the drag force? The drag force is 0. Zip. Why? Because the tau diaphragm and the tau wall are equal. But for the south wall is different story. Tau wall is going to be much larger than 250 because I have a short wall. This wall has only 40 feet and 40 feet here. So total of 80 feet, and I have an opening. So the tau wall, according to equation 9-4, and I am referring to the text again. If there is equation that's taken from a code, I put the equation of the chapter. So this is the text. And we don't have chapter 9 of the ASE 7. Do you remember the ASE 7? The ASE 7, the one we use it, the ASCE 7-16, we have chapter 1 and chapter 2 and chapter 11. This is 1 and 2. They write it this way, by the way, 2, not numerical. 11 and chapter 12 and chapter 13 and chapter 15 and chapter 20 and chapter 21 and the chapter, the one that has a graph at the end. So, and I will be glad to go over all these chapters to tell you exactly, to remind you which chapter, what does it have. So I don't have a chapter 9 even mentioned at all in my book of the ASC7. So when I say, and I will try to remember to tell you, okay, which equation, but it is a textbook chapter or, okay, because there is no code equation. They are talking about, okay, tau wall is equal what? According to equation 9-4. It says also F over 2 over the length of the wall. F over 2 over L sub W. The length of the wall is so easy. It is 40 and 40 is 80, which is 40 feet plus 40 feet. Do you agree with me? Because we have an opening here, 120 feet. But the mystery, where is F? He didn't give me an F directly. If he give me W, as I did in the example problem, I'll multiply W times this dimension, will give me the total F. Half will go this way and half will go this way, because he said that this is a wood structural roof diaphragm. Why I assume that this is a flexible diaphragm? Okay, here it is. Wood framing with the plywood sheathing. Okay, wood structural roof diaphragm. We talked about the difference between rigid diaphragm and flexible diaphragm, and we said that all the wood structural roof diaphragms are flexible diaphragms by default. Flexible diaphragms. That means that the force that is acting on the building, half of it will come this way and half of, so if this is the F, if this is the total F, so I know there's F over 2 this way and the F over 2 this way. Who told me that? Do you remember the 7 rules? If the diaphragm is flexible, the lateral force will be distributed by the tributary area. A tributary area means that this side will take half and the other side will take half. This is a tributary area. But if the diaphragm is rigid, we are talking about a different story. I will talk about it. Did he give me F? No. Can I find F? Because I need F in this equation. Yes. F basically, he gave me the shear, the tau diaphragm, 250 pounds per linear foot. £250 per linear foot. So if I know the length of this, which is 40 plus 120 is 160 plus 40 is 200. So every 1 linear foot, I do have a shear 250 pounds. So the total, so this is F over 2, sorry. Okay, so the F over 2, this side is equal what? Is equal 250 times the 200. So in this case, I can say that the tau wall, let me use the same color to solve the problem. So tau wall is equal what? Is equal F, which is F over 2 in this case, which is this side here. F over 2 is equal the 250 times this dimension, which is 200. 200 feet. This is BLF. And I know the L sub W is 80 feet. If you do this piece of calculation, let's do it together. So 250, enter, 200 times 8 divided, I ended with 250, sorry, and 200 times, just to make sure, 80, sorry, no, 80 divided, I came with 625, 625 BLF. and I will select the answer C. And if you look to my solution, I hope I selected C. All the solutions are given for the 626 with detailed solutions as much as I can. If there is a typo or mistake, please let me know and I will go over it. The thing that we need to learn from here is what is given in the information is so critical to direct my thinking. Sometimes they give you the load, like the problem I made. Here it is. I start with load. This is a seismic lateral load. He has to say that. If he's giving you the shear, this is a different story. The shear along the wall or the shear along the diaphragm. So he skipped one step, okay, in order to confuse you or in order to confuse us in general. Any question about this problem? So the direction of the analysis is very important to know which direction he's talking about, which wall he is talking about. So let us look to the it seemed that I was reading my mind. Do you remember? Already I answered that. The same problem. And again, I apologize that for some reason, I don't know why the north arrow is missing. But if you look to this, you will find the same problem. And it's asking what is the shear along the north wall. Here it is. This is the north wall. It's talking about tau wall, but north. This is exactly tau diaphragm, which is given 250 PLF. And the answer is B as in boy. No discussion. Why? Because why tau wall and tau diaphragm are equal? The north wall, because no openings. And this was illustrated in chapter 9 in this 3D view, the one I told you that I like this picture too much. Here it is. We have a wall here. This wall here, the yellow wall, let me color it for you. So this is a shear wall. And this is a diaphragm. The diaphragm, the top one. Let me color it. Hopefully I can have different colors. The one shows in the deformed shape. As you can see here, these arrows here, this is the tau diaphragm. This here, this is, by the way, on page 388. Tau diaphragm. And let me use the green one as I use it for the problem. Tau wall is this on the opposite side. Tau wall. And you can see the arrows here and the arrows here, they are the same. Tau diaphragm and tau wall are equal. These are equal. Equal. Why? Because this side has no openings. Okay? They are equal. And this is why we are saying that along this side, the drag force is equal 0. No drag. Because the drag force is coming very soon for the problem that we are solving. But if you look to the other side of the building, we do have a wall here, but this wall is short. Why? Because we do have an opening. This is an opening, a door, as you can see. But we have the top plates on the top, we call them collectors, or we call them drag struts. These are collector because they collect the shear. Why do you call them collector? Because they collect the shear from the diaphragm, this tau diaphragm here. It is the same as the tau diaphragm here. They are equal. But who is going to take care of the shear over the opening? We have a plates, we call them collectors. They will collect the shear from the diaphragm and give it to the wall. They deliver it to the wall. Here we have a drag force. A drag force exists. A drag exists or exists. You see that? This is exactly as in our situation here. We'll see that here drag force is equal 0 because tau diaphragm and tau wall are equal. Here now, here the tau diaphragm is still 250, but the wall along the south is 625 more. It has more shear because it's a short wall, because these walls are not the same length as the wall to the north side. Make sense? I needed to be following all this. So in this case, problem number 376, the problem, so no calculations. So it's talking about the north side, the north wall. Here it is. And this is going to lead us to the second topic, which is a drag force. It's giving you the same problem, and it's supposed to be the north arrow also, the same configuration. When I ask the people are helping me, some of them are engineers, some of them are not, so probably my engineering notation sometimes a little bit confusing. This, by the way, this is a solution, but I said let us give it to you to help you. And he said, what is the drag strut force? This is drag force or drag strut force, they mean the same thing. Over the store front window opening. Here is a front opening. Drag force, how many pounds? So let me explain a little bit more as a reminder and also as a refresher. A drag strut force or simply a drag force. And again, let us take hypothetical or a scenario. Let me call it a scenario. Let's assume these are the walls. My drawing is not the best drawing, but here it is. And we do have a continuous wall here. And again, the north arrow. And let's assume that the lateral force is given. $400 BLF. And for the sake of discussion, assume that this dimension here is 25 feet. This dimension here is maybe 75 feet. And this is a flexible diaphragm. Here we said that tau diaphragm is equal tau wall. And let me give you the dimension here. Assume 60 feet. And each one of them is equal to 400. Right now we are expert. Times 60 divided by 2 divided by 100 feet. Correct me if I'm wrong. I just made the problem and I need you to understand. So it's 400, enter, 60 times 0.5 times 100 divided. So it's 120 BLF. Do you agree with me that the tau diaphragm equals tau wall along this side here, the south wall, and each one of them is called 100 and is calculated to be 120 BLF. 400 is given, 60 is given, the total force F. This is the total force F. And the F over 2, I divide by 2, divide by the total length, which is 75 plus 25. Any question about that? Now, we concluded that the tau diaphragm and tau wall are equal, so this is zero drag force. Zero drag force along the south wall. But along the north wall here, this wall is short. This is whatever, windows and doors and display windows, whatever. This is an opening. Tau diaphragm here is still the same because the roof, we said that exists over an opening. So tau diaphragm is still 120 BLF. But tau wall, the north side or north wall, this wall here, is equal what? Is equal the 400 times 60 divided by 2 This is F over 2. Divided by the length of the wall, L sub W. This wall here is only 25 feet. So is equal what? So it is 400. It gives us 480 PLF. So along, if I use different color here, let me try to use as different colors as I can, at least two. So this is the tau diaphragm. Tau wall, I will draw it with different color. It is opposite to the diaphragm direction. Here they are equal along this side. This is a tau wall. Here, the tau wall is here. And stop, because there is no any wall here. So this is a tau wall north, which is, you can see, is way, way more, 4 times the 120 pounds per linear foot, because this is a longer wall, so it will stress less. This is a short wall. It will take the entire shear from the diaphragm. This is the responsibility of this wall, is the diaphragm. What is the load? The seismic load. This is a seismic load. This is a seismic load. Load or force. We need somebody to take care of it. Otherwise, the building will collapse. So the roof will tell, okay, I am responsible to take this to deliver it to the walls. So the diaphragm is a horizontal or nearly horizontal element that is responsible to take the lateral force to deliver it to the vertical resisting elements. We have vertical resisting elements, or we call it lateral force resisting systems, which is LFRS. Do you remember lateral force resisting systems we talked about, or vertical resisting elements or systems? Or sometimes they write it SFRS, seismic force resisting system. Also, this is another abbreviation, seismic force resisting system or systems, if we have more than one. This is the most common one, the lateral force resisting, because it is distributing the lateral force, and the seismic is a lateral force. And this is what, do you remember table 12.2-1? The big table, the biggest table in the code, the one that has 83 systems. Systems, we went over this before, systems. System A, B, C, D, E, F, G, H. H, I think that's it. There is no H, or there is an I after H. I can remember. I think no, only H. This is in chapter 6, the biggest table, and I put it in a very nice way for you. Let me see if they have H and I, or just only H. H is the last one, if I remember. H, oh yeah, H is the last one. Here it is, H. A, B, C, D, E, F, G, H. Okay, so A to H. So sometimes I need to double check, because if I forget something, I will not hesitate to go and check it. So we know the wall, the north wall is more stressed than the south wall, because it's a short. And this is why when we design, we have to be careful about that. As far as the dimensions of the wall, the thickness of the wall, and the material of the wall. So there is a drag force over this opening. Here drag force is equal 0, 0 drag force. Here I can write with certainty that the a drag force exists over the opening. Yes, a drag force. How much? And this is what he is asking in this problem 377. I am on page, by the way, page 147 of the 626 book. How much? How much is the drag force? In fact, this is a solution using my preferred approach. There are three ways to calculate the drag force. This is through diagrams. Diagrams. Which is, I told you that solution using diagrams. I did not invent it. In fact, in Dr. Breyer's book, one of the references, reference number 7, in chapter 10, probably I showed to you. Here it is. Diagrams. Force diagrams. Exactly as I'm going to explain after the break. And this is the collector force or the drag force. In this book here on page 548. If you have the textbook or if you need this page, I can send it to you. This is from the Dr. Breyer's book, which is, they call it the Bible of timber design. If we understand this, I use it for 20 years or so to teach the timber design classes. And so let's take a few minutes break, get some fresh air or fresh water. And I hope that, as I was joking with this morning with everybody, I don't mean to joke about disease or virus. I said that get some fresh air without any viruses, keep the air free from all the coronavirus, because unfortunately the CDC, as you heard the news yesterday, they recommend to wear masks because they found that the virus can transmitted airborne. So it's not as was before. They believe that airborne is not possible. Now they are saying that it is possible. So take all the necessary precautions. Sorry. I believe in this from day one. Even my daughter, as I was telling them this morning, that my daughter was against me to wear a mask. I told her I will do all my best. The moment the virus start to spread, I try to wear mask, okay, as much as you can to prevent any possibility. And unfortunately, as you know, medical staff, they are wearing all this kind of gears and all this kind of suits, the medical doctors and nurses and medical staffs in general. And unfortunately, some of them are infected because little tiny hole here or there, or little tiny mistake here or there, uh, there are, and some doctors passed away, unfortunately. Um, so let us go back again to the fresh air. Try to get some fresh air and stay healthy, please. Okay. Let us come back after 10 minutes from now. Thank you very much. It's almost 2:40, so 2:50 will come back. Thank you. Okay, sorry, I was. So the drag force, this is a force that exists over an opening or will be developed over an opening because of the presence of this opening. We need something to take care of the shear that coming from the diaphragm to transfer it. So the problem I made it before the break, which is this here. There are more than one way to calculate the drag force. And the Dr. Breyer's book, he discussed the three methods. And the diagram, the one I showed to you, is more effective in understanding the concept. So I will use the diagram method or the solution using the diagrams. So if we look to the north wall or the north side of the building, what we'll find, let me move my camera here. I will find there is a force along the diaphragm, and I'm going to draw a diagram for that over the entire length of the diaphragm, which is 100 feet. And I will call this is tau diaphragm. It is uniform over the entire length. And this is tau diaphragm, which is the one we found along the north side. Tau diaphragm is still the same, 120. Like exactly the tau diaphragm along the south. 120. This is 120 BLF. But the wall is only exists over 25 feet. And the remaining 75 feet is an opening. So I come here, try to get it as close as I can as far as the scale. I will draw another diagram. I will call it tau wall. And this is the 25 feet, which is the length of the wall. And the remaining is an opening. And this here is the tau wall. Which we calculate to be 480. The south wall, okay, it is, I will call south wall to make sure. This is 480 BLF. So two diagrams, one diagram for the tau along the diaphragm, which is uniform and constant, and the tau along the shear wall. So far, so good. Right now, we're going to draw another diagram. It's called the net diagram, which is the difference between them. Try to squeeze it in here. We call it net diagram. And after you do this once or twice, you will find that you don't need to draw all these things. So along the opening, what is happening? The diaphragm shear exists. Still the same, which is a tau diaphragm, which is equal 120 PLF. But here, along this portion of the system, I have a wall has 480 up, and this is 120. So the difference between them is 360. The net is 160, 360, sorry. The difference between 480, is this correct? Yeah. So here it is. So this here is basically, it is a 480 minus 120. So 063 BLF, which you call it the net diagram. So if you add this plus this, will give you this, which they call it net diagram. So far, so good. If you look to the area under the net diagram, by the way, this area here, you will find something amazing. This area here is equal what? Is equal the height, which is 120, times the 75. Because we know the opening is 75. This is 75. Here it is in front of me. 75 feet. Let me move this a little bit to the left. Sorry, here it is to the left. Okay. Because I put my dimension here. Here it is. To match exactly the dimension. Here it is. Here it is. Okay. So this area here is equal 120 times 75. And this area here is equal to 360 times 25. If you calculate the area of this diagram and the area of the other diagram, they should be equal. Otherwise, I have something. So 120 enter 75 times is 9,000. And 360 enter 25, amazing, is also 9,000. And this is something that I need you to be aware of. The area under the net diagram, 9,000, one up and one down, one positive and one negative. If you consider this is positive, I have no problem. Consider this negative, I have no problem. Because one tension and one compression, they will not ask you about that, but the net diagram, because if you look to the drag force diagram, right now we're going to draw a diagram. The drag force at the beginning of the wall and the end of the wall must be 0. So the drag force at the beginning here is 0, and here is 0. I needed to be aware of that. So the drag force at the beginning of the diaphragm, sorry, at the end of the diaphragm is equal 0. And after that, it will start to increase until the maximum, and after that, it will disappear. How? Let me draw the diagram on the following page. I was hoping that to squeeze it in here, but it will be very crowded. Let me do it on the following page even. I know it's better for continuity to have it. So the drag force diagram will be like this. This is the side I'm talking about. The north side, I have 25 feet and 75 feet. This where we have the wall, and the rest is an opening. And we can say that the diagram is like this. Here is 0 and here is 0. At this point here, you will find that the value is 9,000. Positive slope, and after that we'll go to a negative slope, and this is 9,000 bound. Start at 0, goes to the maximum here, and after that it will go to 0, because what is happening over this opening here, there are two shear forces. Let me just, one along the diaphragm side, let me use the green one, the red one, sorry. This is a tau diaphragm. Tau diaphragm is equal 120 BLF. I have a collector here. I have a member, the top, on top of the opening, there are two plates, double plates. They will collect the shear. This is what they call them, collectors. Collectors. What they do, they collect the shear from where? From the diaphragm. Every one linear foot, they collect 120. So I need you to use the logic, because the logic sometimes it can solve a problem so easy without too much math. So every 100 and every one linear foot, there is a shear. It's 120 pounds coming from the diaphragm. Who's going to carry it? The collector will collect it to deliver it to the wall, because the collector cannot carry it. Collector just collect it and deliver, because the wall is connected to the foundation. Here is the wall, and the shear wall connected to the foundation, and we need the force to come down to the foundation, and the foundation will take it to the ground, to the soil supporting the structure, because this is all what we do for gravity loads. And the same story for the lateral loads, is to collect the load and to transfer them and deliver it to the foundations, and the foundations will take it to the ground, all the supporting soil. So I have 75 feet. So every one linear foot, I have 120. So 120 feet bound per linear foot. So if I have 75 feet opening, that means that the collector will collect this. Is this correct? The 120 times 75, this is the 9,000. The one we calculated together bound. So the collector is going to collect 120 for the first foot, the second foot, all the way up to here, and deliver the 2,000 to the wall. Here, this is the delivery point. This is where we have the maximum, the 9,000 pounds. The load will absorb all this over its entire length. And this is called, to draw it upside or downside is not a big deal. Positive or negative, don't worry about that, because the load can come from right or from left. Tension or compression is not a big deal. So this is the drag force diagram. This is a drag force diagram. The problem that we have, the opening is in the middle, is not at either end. You see, the opening here is problem 377. It is here. I did the same thing, by the way. Here it is. I draw the diagram, the roof, the 250 for the roof. Here it is. And the walls, the two pieces of the wall, sorry, the two pieces of the wall up, the 625, the one we calculated together, here it is. And this is the following diagram is the net diagram. Here it is. I call it the net unit shear diagram. Let me find a different color here. Hopefully I can find a color that it will make more sense to you. This net diagram. Okay. And finally, I draw the drag force diagram, which comes from zero at both ends, comes here, and the crossing, and here it is. And each one is 15,000 pounds each side. Which is this area, by the way. This area 1, I call it this area 1, and this area 2, and this is area 3. Area 1 is this area here, and the area 1 is this area here, and the area 3 is here. So if you calculate the areas, they should balance. Let me get closer here to see what I meant by all this. This is my preferred way to calculate the drag force. And we need to train ourselves as far as the shape. If the drag force, if the opening, sorry, on one side, like this, I need you to know that the drag force, for example, let me draw another drawing. Let's assume that we have a building that it has two walls as shown. The opening, and let's assume the other two walls are continuous wall or continuous walls. So no drag here, no drag here, but along this here, this side here, you will find that the drag force diagram will be like this. Okay, this one here, drag force diagram will be like this. Let me draw it on the top. This is the drag force diagram, and this is the drag force diagram. Obviously, it is zero at both ends, like the chord force, if you remember the chord force. Okay. But if you look to another scenario, which is the one similar to ours, where you have the opening, it is somewhere not at the end. Okay, like this. I have an opening here and opening here. Okay. So in this case, the diagram, this one here will be, it will come like this. and it will cross, by the way, from tension to compression or vice versa. It will come like this, and it will go back again to zero at the. This is a diagram for when the wall opening is somewhere not the ends as shown here. So this is an opening, and this is an opening, and the same story for the other wall here. If this is the north arrow, I will say the north wall. So in this case, we are talking about something like that, and it will come something like that. It depends on the magnitude, and after that it will go back to zero. So this one here is another diagram. So always start at zero, and after that, another case, I need you to think about it. What about if the wall we have an opening here and another wall in the middle. So I have two openings. So we do have an opening here and an opening here. Like this here, this is an opening from here to here, and this is an opening from here to here. Now we are from here to here, we have an opening, and we have from here to here opening. What will be the diagram it looks like? And I need you to draw it when I scan these things by the end of today. I need you to look at it and let me know what will be the diagram looks like. Okay, if you'd like to have some dimensions, I have no problem with that. If you'd like to consider this lateral force here, at least the numbers will probably make more sense to you, that this is WS is equal 300 BLF, and let us make this dimension here 80 feet, and this dimension here is 200 feet. And we can make this dimension here, or these dimensions, 1, 2, 3, 4, 5. Each one of them is 40 feet. So 40 feet and 40 feet opening, another 40 feet, 40 feet, and 40 feet. This to add up to 200, yes. 1, 2, 3, 4, 5, yes. What about that? So I needed to think about that, about how much the drag force diagram. I needed to practice like this, like a homework, okay? And we'll be glad to discuss it. So when I scan it after the class, don't watch 60 minutes, don't watch anything about Corona nowadays, just focus on your studying and take care of all the, or take care of your health, do all the necessary precautions, wash your hands and stay away from the public and wear the mask and all the necessary instructions given by the experts, and work on the problem. Okay, so this is one topic. I'm glad that when I opened the book, it just hit this topic, which is one of I don't like to say difficult topic, but is a topic that it is something that we need to be aware of, and you might see something on the exam related to this. And there is many problems in the 6 to 6 related to this. There is one specific problem, if I'm not mistaken. Let me, um, uh, if I can locate it very quick. It is in the same concept, but he's asking you. I know too many problems. Hopefully, I can find it. And if not, here it is. No, this is another problem. Yeah, here it is. I found it. Problem 245. Problem 245. If you don't have the book, you can read it and tell me what you think. I will give you 2 minutes, and let me just focus as much as I can and get it as clear as I can. We know the drag force diagram is going to be like this. It will increase from the 0 to the maximum, and after that, it will dissipate over the entire length of the wall. So this is a diagram, because this is an opening here. This is an opening. So we do have a lateral force, a lateral seismic force. And they're saying that how long the south wall should be in order to have a maximum drag force of 1500. So we know the process. This is the load is given here. So it is 400 times 45. This will give us the total force, which is 400 times 45. This is an F. And again, this is a wood structure, a roof diaphragm. So by default, this is a flexible diaphragm. So I know F over 2 will go this way, and the F over 2 will go this way. Without complicating, without using equations, there are some equations available, and I have it in my books also, or diagrams. Just, I need this amount here to be 1500 pounds. We said that we have something that's called tau diaphragm. Do you remember tau diaphragm? The tau diaphragm exists even over the openings. And the same story here. This is a tau diaphragm, which is equal to F over 2 divided by this dimension, which is 60. So the shear along the diaphragm is equal 400 times 45 divided by 2 divided by 60. 60 feet. So if you calculate this number, 445.5 times 60 divided, I get 150 BLF. So along the diaphragm side, I have a shear of 150 pounds per linear foot. So every 1 linear foot along the diaphragm side, there is a shear generated of 150. Over this opening, I'm going to provide a collector to collect the shear from. I'm going to provide a green member here. I call it collector. Here it is, over the opening, to collect. This collector will collect the shear from the diaphragm. The diaphragm, based on the calculations, is 150 pounds per linear foot. I need to be maximum 1500. So how long this opening should be in order to get, so every 1 foot, 150. So 150, another 150, another 150. Over 10 feet opening, I can collect 150 times 10, 1500. This is what he's looking for. That means that what is left here is the wall length, which is 60 feet minus 10 feet is equal 50 feet, and this should be the answer. Agree or disagree? I need you to understand the logic, and after that, equations or diagrams are good. I'm not saying that don't use equations or diagrams or a combination of both, but I'm saying that let us grasp the concept and understand what's going on, because sometimes I can pick up the equation and So we need to be aware of that, please. Since we are on the same page, in chapter 2, you know, the law has the Professional Engineers Act. You need to get a copy of that, by the way. The Professional Engineers Act. You can download it for free. I highly recommend you to download it. And this is written also in the California Board website when they list all the list of references. I believe they mentioned it at the beginning, if I am not mistaken. Let me see if I have a. No, I don't have. I have the actual one. But if I'm not mistaken, I believe they say that. If I'm not mistaken, they are saying that let me go to my website, because the California board, here it is. We put it at the bottom of, so basically if you go to passp.com, the website that all of you are familiar with, and they click here, it will take the California, the professional engineers. Here is the California board, and I will go to exams, and I will go to exam reference material and test plans, and I will go to seismic and surveying. Here it is. So here it is, the Professional Engineers Act. So this is from their website. If you click on it, it will take you, by the way, business and the professions code sections 6700 to 60. Please try to download this because they might ask you something related to this. I include as much as I can, and you need it anyhow for the take-home exam. I believe they include some questions in the take-home exam about um, what an engineer can do, and so on. And here are the references, by the way. This is for surveying. Seismic is here it is, the seismic principle. Okay, this is the CBC, the one I was talking about. But they are saying that based on the International Building Code, IBC, here it is. So you can use IBC 2018. This is the ASCE, the minimum design loads for buildings and other structures. No, the name has changed. I don't know why. And the associated, okay, the name has changed, but they put the old name. But this is ASCE 7-16, but the name is not the same name. They changed the name. This is the seismic design provision for wind and seismic, 2015. This is a masonry one. This is the ATC 20 and the ATC 20-1, the field manual, the second edition. Okay, and this is Dr. Breyer's book, the one I talked about. So now going back to the top of this page, you'll find that the Professional Engineers Act is something that I highly recommend you to get it, because okay. So okay, so so here the same page where we were talking about the drag force, the problem 244, a new two-story for dwelling units unit of wood frame construction to be built at a site of a seismic design category SDCD. We need to know how to determine the seismic design category SDC. It's very important. SDC A through F. Talked about that. And be glad to explain this one more time. And the site class is B as in boy. As you know, the seismic design category SDC, they are using almost the same letters. No, the same letter, not almost. The same letters, unfortunately. So the seismic design category SDC, seismic design category, they have A, B, C, D, E, and F. A being the safest one, and this is why I did not include it in chapter 12 of the ASCE 7. So this is the safest, a place where you can, because a place that does not have any seismic activities, because there are no known seismic faults. And F is the worst, which is basically like the Bay Area next to an active fault like San Andreas Fault or Hayward Fault and all these faults. California, we are here. This California, as I mentioned, California, we have seismic design category D, E, and F. D is majority of them are in Central Valley, Fresno and Bakersfield, Central Valley. And 80% between E and F, which is San Diego, the Bay Area. 80% of the population, they live in E and F. Okay. This is the letters they are using for the seismic design category SDC. The other set of letters they are using for the site class. Site class, which is in chapter 20, if you remember, chapter 20 of the ASCE 7-16. There is one table over there. They took the table from all other codes and they put it only in chapter 20. Site class, basically they are talking about the soil type. This is what is meant. And in the past, they use the letter S, but this code, they drop the S. So the site class or the soil type, basically also it is A, B, C, and D, and E, and F. Right now, this D, they broke it down in this code. We have two Ds right now. D as a default, okay, and I will tell you what is meant by default. And D based on testing. Because there is a statement in the code, and it seems to me the reason they came up with two Ds this time, it has been abused in the past. And I know a case where an engineer, he lost his license or they suspended his license because of that. It has been abused because the code, it says that related to the site class, the code said that if the soil type is not known, okay, you may assume site class D as long as there is no geotechnical report or data to indicate that E and F may be present. So this was a default that I don't have. I have a site. I'm going to build whatever the future building will be. And this site is not known to me. I don't have any geotechnical report. I don't have a geotechnical report. And there is no any indication that the soil type E or F may exist. So I can assume to be D, but they call it this is D assume or default right now, assume. So default. So they became very stringent about that, by the way. They start to say that if you are going to assume it to be D, we will call it default, and you have to use certain criteria for the default. But if you do have testing, actual testing, based on the table, what is the table? Let me show you the table. The table is given in chapter 6 of my book, at the beginning of chapter 6, and this is the table 20.2-1, I believe, or 20.1. It's only one table, and here we go. 20.3-1. I'm sorry, here it is. Here it is. This is the table that given in the ASCE 7, chapter 20, and this is the only table. On page 204, if you have the original document, you can look at it, and I did my best to verify all these numbers in any table that I provided. I did my best, but nobody above mistakes, as I always say, or nobody above typos or errors. So if you do have some properties, obviously soil type A is the best, which is a hard rock. Soil type F is the worst. And every time if you see E or F, or even right now D, if they mention D or E or F in the problem statement, there is something tricky in the problem. I needed to be aware of that. And the soil type F, it does not have any description in the table because they give us the description here in a different section immediately under it. Okay, soil type F. It has another item on the following page. There are 4 items. This item number 1, item number 2, item number 3, and I believe there is another item number 4 on the following page. Here it is. Those are the 4 entries for this, with all these exceptions. As I know, exceptions are really. So I told you during the class that there are 3 possibilities. In any given problem on the exam, there are 3 possibilities. Number 1, he could be very nice and say that static class will be stated in the problem statement. For example, static class C, for example. This is the first possibility, which is nice of him if he told you the static class is so and so and so. The other possibility that he will give you some properties. Given properties like shear wave velocity, this based on ASTMD or standard penetration test, or undrained shear strength. In this case, I will use these properties to go to the previous table. I will answer you, my friend. Sorry, I did not ignore you, but I'm waiting. One of you raise the hand, and after that, put it down. I will look to your question shortly. If properties are given like shear wave velocity, or the standard penetration test, or the undrained shear strength, so in this case, you need to come to this table, and you will pick the the proper site class based on the properties. This is another possibility, which is possibility number 2. Possibility number 3, which is the one they try to make it okay, say that they are saying nothing in the problem, but they are telling you the properties are not known in sufficient detail. So the site class D is used unless the building officials determine that the site class E or F may exist. May or likely to be present. Likely is likely to be if there is a geotechnical report is telling me in this area there are many E's and F's, don't assume it to be D. So those are the 3. Okay, let me just grab the question. I don't know, you put your hand, my friend. Let me look to the question. Show answer. Okay, let me. Oh, you put your hand. Okay, unless I answer it, one of you raise the hand, and after that, I'm sorry. Okay, so let me unmuted you. Yes, Abdul Razak. You have a question for me, Razak? You raise your hand, my friend. I unmuted you right now. You can speak out if you want, or you can write the question if you don't have a speaker. Okay, that's fine. I am ready when you are ready. Okay. So this is the site class or soil type is very important topic, and we talked about it a lot. And by the way, during the break, I was looking for, I found that the last lecture I taught last quarter is still here, including the picture from the textbook I was showing you about the bunching shear. You remember the bunching shear? For some reason, it was not scanned and sent to you. I will scan it and send it today. After this lecture, I will scan both of them and they send it to you. This is called bunching shear. As you can see, the column penetrated through the bridge. It seems to be this is a bridge. So this is called bunching shear. And this bunching shear we talked about in chapter 15 of my book. Bunching shear is a serious issue when you have a flat slab with columns like this. You have a flat slab with columns. So bunching shear is a very common. Okay, so this is a flat slab. And this is a column. Okay, so they found that in a situation like this, the bunching shear is causing to go through the slab and bunch, and you can see it protruded like this. This is a serious issue. Okay, this is, by the way, during the 1995 earthquake in Japan. Oh, and the Loma Prieta earthquake, by the way. Also, they mention about 1989 Loma Prieta earthquake. So the bunching, here it is, the word bunching shear, here it is, you see, in the discussion. In order to minimize or eliminate the bunching shear, you will find that when they build bridges, we don't make this scenario, or even for buildings, we make, if this is a slab, we increase the contact area by doing this. Drop panel like this, or so the shear that's coming from the column, because this is a column, which is a concentrated load, it will be distributed over a wider area, so the shear will be less. or sometimes they do this. They stepped it like that. And they probably saw this. Some designer, they prefer to do this in order to reduce the shear. So drop, okay, and all these things shown in my book, by the way, explain it. Or for bridges, for example, what we do, normally we do this, okay? So we flare the end of the column in order to increase the shear area, so the shear stress will be going down. So all these things are very, very important. So I will scan it and send it to you. And this is a picture of when we talked about shear walls, and we talked about the shear stress for shear walls. Do you remember shear walls? Shear walls, okay, and the spacing between nails. So we here we're talking about, we have the vertical studs, as you can see here, these vertical studs, and normally spaced 16 inches in center, and we put the plywood, could be, or gypsum board, whatever, and applied directly, and we put nails. There are two types of nails. We normally discuss them. Something is called the field nailing. Field nailing like this, the nails inside or away from the boundaries. All these are field nailing. But the nailing around the boundaries, they are different. Here it is. At the edges. At the edges here, the nailing along the edges are different spacing other than the field nailing. So I need you to be aware of that. We talked about this in chapter 9 and chapter 10, but I promise you there is a picture. And let me, here it is. And this is supported by the concrete slab, sorry, the foundation, the concrete foundation. Could be a slab, yes. Could be a slab or it could be a footing, as we talked about it. And so I found the lecture of last time still here, is not filed yet. So I will scan it and I will send it to you. And it does have a lot of interesting topics we talked about it. So I will include it when I scan the lecture tonight. Okay, that's something that just I noticed. I know because everybody is working remotely, so I am trying to do as much as I can. It seems to me there is a question coming from a friend. He said that that's okay. That's correct. Okay, and in your note, you mentioned if the soil type is not known in sufficient details, in this case, we can assume it to be D unless there is any geotechnical report indicating that E and F may exist. Yeah, that's correct. Okay, if the soil type is not known, you may assume to be site D, site class D. D is the default. Okay, as long as no geotechnical report, no geotechnical to indicate that E or F may exist or most likely exist, as they call it in the code, most likely. I know the codes are written in a language. Yeah. So this is the statement. Here it is. Could they mention that? Here it is. If the soil problems are not known in sufficient details, sufficient detail, site class D is used unless building officials or geotechnical data determine that the site class E or F, site class F, is likely to be present at the site. Okay, so this is, they still have this statement over there, but in this case, they are talking about the D and D fault. And as you remember, I send you some stuff. I don't know if you have it for the SDS and SD1, the one we calculated together one time, the acceleration. When we come to D, we have two columns, one for D and one for default. Default or assumed. So you'll find that two columns, and I can show you this, please. So this is what is meant by the code. I don't know if the language is still making difficulty, or if you agree with me, that's good. If you disagree, please let me know, and I would be glad to correct it if you find something in the code otherwise. I mentioned not. If the soil is not known, yes. If the soil type is not known, thank you. So our friends say that I missed the not here. Yes. If the soil type is not known, that's correct. You may assume that's correct. Thank you. Yeah, he said that the word not is missing. Thank you. Okay. So the D and the default, there's something new, and I need you to be aware of that. Okay. So all these questions are very okay. Going back to the question I was referring to. Sorry, I try to elaborate as much as I can, and probably next time I will, as I said that, probably I will prepare the questions, which I will extract them from him. I'm not going to reinvent, and I can rearrange the questions in a way that will cover, for example, next time, for example, chapter 1 and chapter 2 and chapter 3 and chapter 4 and chapter 5, for example. I can pick so this is like, and I will email it to you, and you can work it out, and after that we'll solve it together. After you try on your own, okay? And like I will call it like mini exam. I'm not going to give you 55, or I can make it 55. I says, what about that? I will make it 55. So 55 questions, and I try to spend 2.5 hours and solve it in your own using references. Take it seriously. I will do that. I can collect this, and every time we meet, I can generate 55 questions and send it to you. But I will go in order. Okay, for example, chapter 1, and this 55 questions are related to chapter 1, 2, 3, 4, 5, which normally I cover it in one day. Okay, and after that we'll go to chapter 6, which is the lengthy chapter, seismic design requirements for building structures. And so on, chapter 7, and so on, all the way until chapter 16. Okay, so maybe I will do this. Okay, at least. Okay, so when we come, we'll say that, okay, please go to the on-demand and watch the on-demand videos. Okay, and the on-demand videos are arranged also by this way, the same way. Okay, the staff are helping me with that. They are working on that. Hopefully that it is done or very close to be done. So the on-demand will be also to go to the Seymour chapter 1 all the way, so you can, and I told them if you can write something on each recording to indicate this chapter 1, please do it, and I think they will. Even they break, because the course, when I taught it, it was 8 hours or 7 hours, 7 hours, not 8 hours, 7 hours. So they call it session 1A and 1B. They call it session. To make it easy for you, session 1A and 1B, in order to, especially for the download, especially nowadays, the internet extremely crowded, you. Okay, everybody is downloading, as I said, that movies and communicating with the whole world about families and relatives. So the internet is so busy, It crashes a lot, and we are suffering a lot through this. But what can we do? So bear with me, and I will do all my best to help you as much as I can. Let's go to this question here. A new story for so and so. This is static class D and seismic design category. Who can design and sign the plans among the following licensed and unregistered individuals? Who can? It is an architect can do it. Okay. Or a structural engineer, or a civil engineer, or unregistered individual. Okay, obviously the SE an SE can design any building. Okay, in fact, there are some buildings cannot be designed unless you are SE. Public schools, hospitals cannot be designed unless designed by an SE. A civil engineer, BE, or even he did not receive his BE, a civil engineer, he can do it. An architect, he can do it. So the category that might surprise you, that category 4, an unregistered individual. And this is 2-story, 4-dwelling unit. It must be like that. 2-story, 4-dwelling unit. You'll be amazed that also they are entitled to do it. And this is answer D. Who said that? Not me, not anybody else, but the code. So I need you to Building Design Authority Guide. I put this in chapter 2 of my book, and I will double check it one more time because sometimes they change. But in my book in chapter 2, let's go to chapter 2, and the one that has a summary of the Professional Engineers Act, by the way. I know too many codes, and here it is. Building Design Authority. I got this from their website, Building Design Authority, and I will double check it one more time. So a structural engineer may design any building of any type. Civil engineers may design any building of any type except public schools and hospitals. So public schools and hospitals. And an architect, he may design any building of any type except the structural portion of a hospital. Unlicensed individuals may design only the following types of buildings, and they have listed these. So this is what is written in the code. Okay, so going back to the question related to this is what. Okay, let me stop here today because for some reason I have some headache. I have no idea why the headache is. But next time, what I will do, and for those who are joining me the first time, I know some of you are joining me the first time. Let us watch the on-demand. And if you have any problem, please let me know, and I will do my best to help you. On-demand, chapter 1, 2, 3, 4, and 5. Okay. Watch them very well, and I will send you 55 questions extracted from the 626. I'm not going to come up with the new problems because more than enough. These problems more than. So 55 questions related to these chapters. And I need you to work them seriously. And when we meet next time, we will go over them and see how many questions you have concern about it, and we can do that, and I will do all my best to help you. Okay, so let me stop here, and I will do all my best next time. I will scan the stuff and send it to you right now, but I don't know when they are going to open the testing centers again, but let us be ready just in case if they open it for those who are supposed to take the exam and the first quarter. They may open the centers. I don't know when. I have no idea. Nobody even knows, as far as I know. But let us prepare ourselves such that if they announce it suddenly, or I hope this virus will stop or will disappear as quickly as we can. So in this case, everybody will go back again to the drawing board. And so I will scan the two lectures, today's lectures and last lecture, and I will send it to you. And do your best and stay safe, and I will do all my best, and I will do all my best to stay safe, because health is number one. If anybody who is not healthy, we cannot do anything. If I'm not healthy, I cannot do anything. If you are not healthy, you cannot do anything. And let us do our best to stay healthy. This is the ultimate goal, and take it seriously, as I mentioned before, because it is a serious matter, as the doctors and the health officials in this country, CDC and NHI and all this, they are telling us it is a serious matter, so we have to take it seriously, and I wish you the best. Okay, good night, everybody. Just keep working, and I pray for you, and you pray for me. Thank you very much. Good night, everybody.